Hey guys, and welcome back to another video on the channel. In today's video we're going to be solving a connected, I think it's connected particles problem pretty much, but pretty much we're just trying to find the tension in these two strings here with a particle here, 5 kilos, being hung down, okay? Now we don't need to pretty much worry about working out what the force due to gravity is, because the units of this is in kilos weight pretty much, so it's basically accounting for the force due to gravity in it, okay? So we don't need to work out anything using F equals ma, we can just use straight up these units here, okay? Righto, so in this question here, we can see this block is hanging in equilibrium, so it's not moving, it's just staying there due to these two strings here. Now, because they're at the exact same angle, these two tensions are going to be exactly the same, okay? Now, the way we've got to think about this is in terms of the vector components, okay? So the vector components holding this thing up is strictly the force, imaginary force, well, not imaginary force, the force through here, okay? Now, this force here is the sum of both of these vector components here. So this component here and this component here, okay? So this green bit added with this green bit gives you this middle green bit, okay? So we can work out what this angle is here, because that has to be 90 degrees. So this means this angle in here must be 45 in both of them, okay? So this is 45 degrees, and this is also 45 degrees. Now while we're at it, we're going to need this component here and this component here to show that T1 is equal to T2, okay? Because your ups equal your down. This tension here, pulling on this tension here, means the block doesn't sway left or right pretty much, okay? Now these forces are corresponding up here pretty much, okay? So you can project those parallel things there. And we can see we can get this equation here. So, well, not this equation, this is pretty much the setup, but we can work them out using these triangles. So the first triangle we have is pretty much T1 is here, so tension 1, and we have 45 degrees here, okay? So this is the opposite side of my triangle, so this is going to be T1 sine of 45 degrees. And this is my adjacent, so this is going to be T1 cos of 45 degrees, okay? So this corresponds with the pink bit there, that's that force there, and this corresponds with this force here on that respective triangle, okay? Now if you did the exact same thing on the other side, you would work out that this is T2 cos of 45 degrees, and this is T2 sine of 45 degrees, okay? Now because this force and this force are equal, we can basically say that this is equal to this. So what we get is the equation T1 sine 45 degrees equals T2 sine of 45 degrees, okay? Now you can see that both of these things here, sine of 45 degrees is on both sides, so we can actually effectively divide both of them, and we get T1 equals T2. Now that's useless at the moment, but it proves our initial statement that both the tensions are equal, okay? Now, the next equation, your ups have to equal your downs. So this force here, this green bit here, is the sum of this force and this force here, okay? So what we get is, all right, T2 cos 45 degrees plus T1 cos of 45 degrees. Now, this force is counteracting the 5 kilos downward, so it's equal to your 5, okay? So what we get is this final equation here, okay? So, oh, we forgot the top of the T. Move that down. We also know that this is true, so we can actually substitute this one here for T1 as well. So what we get is T1 cos 45 degrees plus T1 cos of 45 degrees equals 5. Now you can see here, these are the exact same thing, so you can put a times 2 in front of it, so you get 2T1 cos of 45 degrees equals 5. Then you can divide by 2, so T1 cos of 45 degrees equals 5 on 2. Now we can work out what cos of 45 degrees using our special triangle. So we have root 2, 1, 1, 45, and 45 here. So cos of 45 degrees is going to be 1 over root 2. So we get T1 equals, T1 times by 1 on root 2 gives you 5 on 2. Then we can just times both sides by square root of 2, so you get T1 equals 5 root 2 on 2, and this unit is kg weight, okay, because the rest of it is kg weight, okay. Now because T1 is equal to T2, this is the exact same answer for T2, and that's how you answer this system of connected particles. I'll be posting another one where the angles aren't equal in this case here, but it's the same scenario pretty much, making the components equal to the components and getting two simultaneous equations. Alright, I'll see you in the next video.